We're continuing to talk about primarily pyramids today. You'll have a worksheet tonight that has pyramids and some cones on it. We'll go over that before you take your quiz tomorrow. But one of the things that happens occasionally is you're not given all of the pieces that you need in order to find particularly the surface area, actually the lateral area. A lot of times you're not given the slant height. So the question is, well, what the heck do I do if I'm not given the slant height? Yes, but the question is, how is that found? And it's almost always Pythagorean theorem. Morrissey, you with us? No. So let's take a look at these two examples, neither of which give you the slant height. They both give you something else. So on this one, find the surface area of a square pyramid with height 8 and base edge 12 centimeters. You're like, okay, so the height is 8 and the base edge is 12. So let's go ahead and do what we would normally do, which would be start with the base, find all the things you need to find about that. The perimeter of the base, there's 4 sides that are all 12. So that's 48. Morris, are you okay? Seriously, you all right? Okay. And then the area of the base, it's base times height. So it's 12 times 12 is 144. Then we're ready to find the lateral area. The lateral area, I know it's been almost a week since you've thought about any of this. Someone remember the formula for the lateral area? Okay, I need to have, there's too many inputs at this point, so yes? No. No.
Perimeter of the base on the slant height.
No.
144 times 8 times 0.5?
No.
1/2 perimeter times slant height.
There you go. 1/2, because the lateral faces are all triangles, times the perimeter of the base. We still want to go all the way around it, but we're not going to go straight up. We're going to go up at an angle to slant height. Thank you very much, sir. Pardon? Well, that's the whole purpose of this, as I said at the beginning of the lesson. So the question is, how do we find the slant height in this case? Well, remember that the slant height goes from the vertex to the center of one of the sides. Doesn't really matter. Down the center of one of the sides, one of the lateral faces. And you're like, okay, that's great. Well, I can connect those. And that's a right angle. Now, if I was looking at this square, what part of the square is this piece right here? No, I didn't ask for the number. I asked for its name. It has a name, one word. It's the apothem. Because it goes from the middle to here, right? Now, the nice thing is if it's a square, it's really, really easy. What is that apothem going to be? It's 6. Because this is a 45, 45, 90 triangle. So I know that this distance is 6. If it is some other figure, it's a little bit harder. You're going to have to work with it. But you probably, if it was some other figure like a hexagon, you probably already have found the apothem because you needed it to help you find the area. All right, so now I've got this right triangle, and I can do the Pythagorean theorem. Yep, 6 squared plus 8 squared is equal to the slant height squared. Some of you already have that one memorized. It'd be nice if everyone had this one memorized. So the slant height is 10. So we have 1/2 of 48 times 10. 240, exactly. And then they ask us for the surface area. The surface area is the lateral area plus the area of the base. And it's just 1 because there's only one base. Exactly right. So that's 240 plus 144. 384 square centimeters because it's area. So that's what you're going to do if you have the height but not the slant height. What do you need the height to help you find? The volume. You need the height to help you find the volume. All right, let's take a look at the second one. Given a lateral edge. So find the surface area of a regular hexagonal pyramid with lateral edges of 13 and base edges of length 10. The lateral edge and the slant height, gentlemen, is there a question? You ask me. Otherwise, okay, you can get it in a moment then. So the lateral edge and the slant height are never the same length. Never, ever, ever. On this model, here is the lateral edge, right? The slant height is right down the middle of that face like that. Which one of those is shorter? The slant height is shorter. And if you just think about it in, fastest way to the bottom would be to go right down that, not down this. Not to mention that this is far less comfortable. But that's another story. So, let's take a look at this one. Again, we'll start with the base. So, what is the base of this? A hexagon. It tells you in the problem. It says it's a hexagonal pyramid. Oh, sorry. Let's try that again. All right. It says the base edges have a length of 10. So I'll go ahead and find the perimeter. 6 sides at 10 each makes 60. The area of the base, who can tell me the formula for that?
1/2 apothem times perimeter.
There we go, 1/2 apothem times perimeter. So we got to find the apothem. Because what kind of a triangle is this?
30-60.
It's a 30-60-90 triangle. Most of you have gotten that one memorized. We've done hexagons so many times. So that's 5 square roots of 3 times 60 is 150 square roots of 3. Then the lateral area is 1/2 perimeter of the base times the slant height. So it's 1/2 of 60 times, and we don't have the slant height. But if you think about what the lateral face of the pyramid looks like, so you're just looking at one side of the pyramid. It's a triangle, right? Where these are the lateral edges, 13, and this one's 13 also. And what is this down here?
10.
Yeah, it's 10 because it's a base edge. And the slant height goes right down the middle of the lateral face. So each of these is 5. And some of you know this one. 12. If you don't know that, do the Pythagorean Theorem. 5 squared plus the slant height squared is equal to 13 squared. So 25 plus the slant height squared is 169. So the slant height squared is 144. So the slant height is the square root of 144, which is 12. So now I can put that in here. The lateral area is 360. The surface area is the lateral area plus the area of the base. So that's 360 plus the area of the base is 150 square roots of 3. And we can't combine unlike terms. Some people say that you can't add unlike terms. That's just wrong. You can add unlike terms. I just did. You just can't combine them when you add. Okay? And then the units on this, oh, no units were given. I don't have to put units on the answer. Any questions? All right. Like I said, got a worksheet for you.